Let's have some fun with fascicular blocks. You might also hear these referred to as hemiblocks, but we're going to get into the anterior fascicle and the posterior fascicle and how we block those off and how we can see those on the 12 lead. So your fascicles come off of the left bundle branch, and we have a left posterior fascicle and a left anterior fascicle. So we can block off our left bundle branch block, or left bundle branch block. We can block off our left bundle branch, or we can have a block further down the road, and we can block off our posterior fascicle, or we can block off our anterior fascicle. But one is more common than the other. Our anterior fascicle is pretty organized, pretty thin bundle of fibers. Those fibers are then going to branch off into the Purkinjes, which innervate the anterior lateral walls of our left ventricle. And then our posterior fascicle is pretty loosely dispersed, hard to block off because it's fanned out. So the electrical impulses can kind of like jump around a little bit more freely if we try to block off the posterior fascicle. So posterior fascicle hard to block off because it's so loosely and fanned out, or loosely dispersed and fanned out. Posterior fascicle is going to innervate the inferior and posterior walls of our left ventricle. So with hemiblocks, with these fascicular blocks, one of these fascicles, not the entire left bundle branch, is blocked off, but one of these fascicles is blocked off. So our anterior fascicle is blocked, or our posterior fascicle is blocked, and that creates a left anterior hemiblock, or a left anterior fascicular block, or a left posterior hemiblock, or a left posterior fascicular block. And each of these create kind of a directional issue, directional problem. So in this example, this diagram, my left anterior fascicle is blocked off. So that creates this flow of electricity this way into the left posterior fascicle. Similarly, if I block off my posterior fascicle, kind of creates a different direction for my electricity. So I've got this blockage, this little highway, this little road is blocked off, so I have to go a different direction. So that's what we're going to focus on. We're going to focus on direction. And with our hemiblocks, with our fascicular blocks, right? When we block these off, all of a sudden, this left ventricle is aberrantly has this aberrant conduction. And it's weird. It looks weird. It looks nasty. It looks, I don't know. It's just odd. And we're altering our vectors. And we're looking at the left ventricle, and we have left ventricular dominance. You remember that? You remember left ventricular dominance? Because left ventricle is kind of big. It's kind of the big bully. It was like, if you're looking at the EKG, you're looking at me, right? So with the fascicular blocks, these hemiblocks, we are altering the vectors in our left ventricle. So when we go to diagnose fascicular blocks or hemiblocks, and I'm using those interchangeably, I apologize. Hemiblocks and fascicular blocks, same thing. When we go to diagnose hemiblocks, it is all about ventricular axis. That's it. Kind of, sort of. That's it. Look at axis. Is axis weird? You probably have a hemiblock. Maybe. Kind of, sort of. So the first thing we're going to look at when we diagnose a hemiblock is axis. Case in point, left anterior hemiblock is pathologic left axis deviation. I promised you that would come back. Promise. Here it is. Pathologic versus physiologic. We broke it apart for a reason, and here's the reason. Left anterior hemiblock is pathologic left axis deviation. So if we're looking at the numbers between negative 30 degrees and negative 90 degrees, if we're looking at the leads, lead 1 is up, AVF is down, negative, and lead 2 is negative. So lead 2 is our, in left axis deviation, our kind of decider. So lead 2 here is negative. I've got a pathologic left axis deviation, and that's it. That's the start. That's the end. Don't overthink this. That's it. You see pathologic left axis deviation? You have a left anterior hemiblock. Shabam. That's it. Do not just don't overthink this, please. To diagnose a left anterior hemiblock is pathologic left axis deviation. Start and finish. There it is. Here we have a left anterior hemiblock. Lead 1 is up, AVF is down, left axis deviation. So we look at lead 2. Oh, lead 2 is down. It's a pathologic left axis deviation, and pathologic left axis deviation automatically equals left anterior hemiblock. So let's look at this EKG. Everything's looking good. Normal sinus rhythm. It's not too wide. We like that. Or at least cure us wise, not too wide. We like that. Let's look at axis. Lead 1 is up, mostly up. AVF is down, mostly negative. We have left axis deviation. What about lead 2? Is that up or down? It's mostly down. We have pathologic left axis deviation. Pathologic left axis deviation automatically equals, drum roll. You have to do your own drum roll. I can't. I'm sorry, I can't do the drum roll for you. You have to do your own drum roll. So this is, drum roll. You're not doing it, are you? You're not doing your own drum roll. Okay. So drum roll, I'm doing it in my head. Drum roll is pathologic left axis deviation is a left anterior hemiblock. Well, that was pretty easy. Left anterior hemiblock. Let's move over to the left posterior hemiblock, which is a little, I don't know. It's got a couple extra things in it. Left posterior hemiblock, a little bit more uncommon because the posterior fascicle super fanned out. Think of like a big palm leaf, really difficult to block. The electrical impulse can kind of jump around any physiological blocks, and the lesion to block off the entire fascicle would have to be pretty big, pretty large. But your posterior hemiblocks, we have an axis of 90 to 180 degrees positively. That would put us in the right quadrant. So we have right axis deviation. And then we have an S wave in lead 1, Q wave in lead 3. We have this S1, Q3 pattern. So for our criteria, we need a right axis deviation. We need an S1, Q3 pattern. And then we need to exclude a couple other things. So we've got those first two things, but then we need to exclude right atrial enlargement and right ventricular hypertrophy, because both of those things, right atrial enlargement, right ventricular hypertrophy, are much more common causes of that axis deviation. So we're looking at a few things, and we'll kind of put this all together as we cover atrial enlargements and ventricular hypertrophies, but we've got a couple criteria where we need to be in the right quadrant. We've got an S1Q3 pattern, and then we need to exclude issues with the right atrium and the right ventricle. So again, we're looking for right axis deviation. We have a right axis deviation. Kind of gives us an indication for posterior hemiblock. And we're thinking like this might be a left posterior hemiblock. I've got right axis deviation. It might be a hemiblock. Maybe. So our second step is there an S1Q3 pattern? Is there an S wave in lead 1? Well, there's always an S wave in lead 1 in right axis deviation. But is there a Q wave in lead 3? There's not always a Q wave in lead 3 with right axis deviation. So look at lead 3. Is there a Q wave? Even like a teeny tiny itty bitty little thing of a Q wave in lead 3. Is there a Q wave in lead 3? If there is, then we need to move on to the last step, and that's our rule outs. And we need to rule out the more likely causes of our right axis deviation. And that's atrial enlargements, ventricular hypertrophies, and ventricular rhythms. So if they're in VTAC, treat the VTAC. Don't go like, they have a left posterior hemiblock. No, they're in VTAC. You should treat that, right? So these are our steps for the posterior hemiblock. A couple extra steps in relation to the or relative to the anterior hemiblock, but starts with axis deviation, looks for an S1Q3 pattern, and then rules out a couple other things. So let's look at this EKG, and what do we see? Let's look at axis. Let's start first with rhythm. We have a normal sinus rhythm, P waves. They're normal with our QRSs. So let's go to axis then. Lead 1 is mostly negative. AVF positive. So we have right axis deviation. So we're thinking, well, maybe that's a posterior hemiblock, a left posterior hemiblock. Well, we have a couple extra steps to go through. So we've got right axis deviation. Okay. Well, what about an S1Q3 pattern? Well, we obviously have S waves in lead 1 because we have a right axis deviation. That's always going to happen. But what about Q waves in lead 3? And you're like, oh, is it a Q wave? We have these like teeny tiny Q waves. Look at those. They're so cute. Oh my lord. Look at that. We do have Q waves. They're tiny, but they are there. So we have an S1Q3 pattern. That's awesome, but we need to rule out right atrial enlargement, right ventricular hypertrophy, and we haven't gotten there quite yet. We will in a week or two, a few more lectures, but we don't have right atrial enlargement. We don't have right ventricular hypertrophy. For the time being, you're just gonna have to take my word for it. So here we do have a left posterior hemiblock. Okay, so we covered our fascicular blocks, our hemiblocks, but let's talk about our bifascicular blocks, because there are really three fascicles in our heart. You've got your left anterior fascicle, you've got your left posterior fascicle, but also your right bundle branch is its own fascicle, because it doesn't branch off from itself. So we've got three fascicles, your right bundle branch, then your left anterior and your left posterior fascicles. And we can block off two of those at a time. So your bifascicular blocks is going to be a right bundle branch block and a hemiblock. So right bundle branch block and the blocking of either your anterior or your posterior fascia. With our bifascicular blocks, we're going to have a wide QRS complex. And if we look at V1, we're going to have a right bundle branch block always. So looking at our J point and using our turn signal method, it goes up. I'm thinking right bundle branch block, right? So I'm going to have slurred S waves in V6 and lead 1. Might have rabbit ears, might not have rabbit ears, but we'll probably have rabbit ears. And then I'll either have a posterior hemiblock or an anterior hemiblock. So I'm going to have a right bundle branch block and either right axis deviation. So lead 1 is down, AVF is up. That's right axis deviation. Or left pathologic axis deviation. So lead 1 is up, AVF is down, but lead 2 is down, is negative. So I'm going to have right bundle branch block with findings of right axis deviation or left pathologic axis deviation. Here we have a normal sinus rhythm. We have lead 1 is up, AVF is down. So we have left axis deviation. Well, we're not going to stop there, right? If we see left axis deviation, is it physiologic? Is it pathologic? So 1 is up, AVF is down. Well, that's left. Let's look at lead 2. Lead 2 is down, so we have pathologic left axis deviation. So if I have pathologic left axis deviation, I automatically have what? I have a left anterior fascicular block, a left anterior hemiblock. But here we have a wide QRS complex, and if I look at lead 1, look at the J point, I go backward, I go up, I'm thinking right bundle branch block. I've got slurred S waves in lead 1 and in V6. So I have a right bundle branch block. I also have, rabbit ears in V2. I have a right bundle branch block and I have a left anterior hemiblock. Hey, look, I have a bifascicular block. Similarly here, and this is things running into things, so excuse that, but I have a normal sinus rhythm. I've got some PVCs here and there, but normal sinus rhythm. Lead 1 is up, AVF is down. I have a left axis deviation. Lead 2 is down, is negative. I have a pathologic left axis deviation. QRS complex is wide. If we go to the numbers, QRS is 0.158 seconds long. That's long. It's wide. I go to V1. V1 looks like a right bundle branch block complex. I go to confirm in V6 and lead 1. I do have slurred S waves. Look at that. Slurred S waves. Right? We're going to cut out this aberrant beat. This what looks like a PVC, but I have slurred S waves in 1 and V6, so I have a right bundle branch block. I have left pathologic left axis deviation, so I have a bifascicular block. And look at that. I have a left anterior fascicular block. I have a right bundle branch block. I have a bifascicular block right here. Even the computer got it right that time around. Imagine that. So this is another example of a bifascicular block. Our last one, a little bit different. Lead 1 is down, AVF upright, right? V1 looks like right. We've got slurred S wave there. We've got slurred S wave here. And what we're looking at is a bifascicular block, but instead of a anterior hemiblock, anterior fascicular block, we have posterior. So we have right axis deviation. We've got a posterior hemiblock in this one, right? So lead 1 is down, AVF is upright, V1 looks like a right bundle branch block. We've got slurred S waves here and here, right? And slurred S waves. We have right axis deviation, but we also have a right bundle branch block. So we have a posterior hemiblock because we have right axis deviation. We have an S1, there's an S wave in lead 1, and Q3, we have a teeny tiny Q wave in lead 3 pattern. We don't have right atrial enlargement or right ventricular hypertrophy, so just take my word on that for right now. We'll hit that here in like a week or two, but we don't have that. So we have a bifascicular block with a right bundle branch block and a left posterior fascicular block. After all of that, if you have any questions, please reach out and let me know.